Hey everyone, my name is Antonio Perez. I'm going to be talking about salinization. Salinization is a process by which water-soluble salts accumulates in the soil, making it difficult for plants to engage in water and nutrient uptake. A major process of land degradation that decreases soil fertility and a significant component of desertification processes in the world's dry land. Soil salinization is also caused by inappropriate irrigation practices that affect about 60 million hectares of land worldwide. Um, what are the problems caused by salinization? There's a few different problems that are caused by the high salts in the soil. Accumulated salts can lead to poor plant health, which eventually is a result of nutrient imbalances in the soil and also less available water for plant uptake. The osmotic stress is reduced on the plant, um, which leads to reduced plant growth and yield reduction in crops. Um, there's ion toxicity, more focus on sodium and chloride. Water infiltration and percolation are also affected during irrigation events, whether if it's flood irrigation or overhead sprinkler irrigation or even rain events. A lot of this leads to waterlogged areas and development of disease development environments, which is a lot of the water standing in the field can lead to high humidity. Plant wilting, complete cross loss, and salinization, if severe, is also going to be plant stress, and furthermore, a decline in soil ecology and biodiversity. How to remedy salinization? There's a few different ways, culture control methods that can remedy the salinization. One of the things is if it's an agriculture setting, the leaching of sodium below the root zone with off-season overhead sprinkler irrigation will leach the salts below the root zone or where the plant's going to be at. Usually, the leaching session will last about 72 hours of straight overhead sprinkler irrigation. Another thing is you can plant salt-tolerant crops such as beets and spinach, and avoiding those sensitive crops to high salinity such as legumes and lettuce, green beans as well. You can also add soil amendments to the soil, such as gypsum, which is calcium sulfate, the addition of compost to increase soil water holding capacity. Um, and furthermore, uh, in my opinion, one of the important ones is efficient irrigation practices that can include drip and sprinkler irrigation that deliver water directly to the root zone. And furthermore, the use of high quality irrigation water with low salts and bicarbonates, whether if that's from the Colorado rivers as a source or well water.
Hey there, it's Gustavo, and I'll be discussing soil degradation briefly for this section of the presentation. Soil degradation is a process that lowers a soil's ability to produce goods or services. It can be categorized into four main types: physical, chemical, biological, and ecological. Soil degradation is a serious problem that will cost the world economy an estimated 23 trillion USD by 2050, according to the UNCCD. 12 million hectares of land are degraded each year, which is equivalent to 23 hectares per minute, according to the FAO. This is roughly 56.83 acres a minute if you convert that metric into acres. This is a fact I want you to keep in mind for later. Now let's look briefly at the right hand of your screen. This figure is provided by the USDA and it measures concerns farmers have about the different types of soil degradation and the support they've been receiving from the USDA. About 49% of farmers are reporting concerns. They are mostly worried about water-driven erosion, soil compaction, and poor drainage. While the amount of fields reporting concerns is higher than the percentage receiving assistance, we can still see that farmers are being proactive in trying to stop soil degradation and the problems it's been causing. In the next slide, we'll go over some of the problems soil degradation causes. I'll see you on the next slide. Getting into the problems, let's start with desertification. Desertification is the degradation of fertile lands into arid desert land. It's caused by human activities like deforestation, poor farming practices, having unprotected soil, and the overgrazing of lands. as well as natural causes like wind erosion. Wind erosion carries unprotected fertile soil across the land, stripping it of its nutrients. We could think of the Dust Bowl of the 1930s as our best example of wind erosion, causing millions worth of damage to plants, humans, and the environment, polluting the land with dust, reducing the air quality, as well as shaping the land around it. A good picture for desertification is right here on the right. That's what it looks like. Another problem we can see is caused by water-driven erosion, and that is caused by poor irrigation practices, heavy rainfall, and runoff, evident in the two pictures on the right that I got from Pexels.com of a city in Colombia, which is right here and right here. This was the main concern by U.S. farmers across the different fields of crops we saw in the previous slide, and it's easy to see why. The torrent of water changed the land, carrying fertile soil downstream, creating a gully and even creating a landslide as seen in the bottom right picture. Soil compaction is another problem in soil degradation. It is caused from the use of heavy machinery as well as overgrazing. This reduces the space between the soil particles and hinders the movement of oxygen, stops nutrient retention and water retention of the soils. Soil compaction is also caused in conjunction with water-driven erosion. So all these problems I mentioned earlier alter the soil, reducing its ability to provide goods, support life, and even contribute to climate change. As devastating as these pictures look on the screen, there are different ways we can combat these problems from occurring, and I'll get to that into the next slide. There are several ways we can combat soil degradation as pictured in the Climate Smart Farming Systems graphic I got from Farmers and Ranchers in Action's website, pictured on the left side of the screen, many of which I won't get to cover today. However, I will go over some of my favorites, which include variable rate fertilizer application technology. I found variable rate fertilizer application technology to be great because it uses technology to map fields, and it controls the amount of fertilizers needed to be applied to those fields. However, I believe its adoption will be slow because it requires high capital investments in technology, and the time needed to learn how to use the technology. But we can look at some more tried and true methods such as no-till farming and cover crops. No-till farming is a technique where farmers plant seeds directly into the soil without tilling it. They also leave a crop residue to serve as a cover crop to protect against soil erosion. According to the USDA, about 1/5 of farmers practice no-till methods, and they save 580 million gallons of diesel every year. That's a lot less labor on the farmer's end, and that's a lot of cost savings because they no longer have to drive their tractors as often, and they can save that money on fuel. We can see the other benefits of no-till farming and the benefits of no-till farming graphic on the right-hand side of the screen, which include less soil erosion, improved soil health, and less need for fossil fuel powered machinery, and even better water quality due to the decreased sediment runoff. We can also look at cover crops as another way to combat soil degradation. Cover crops are relatively easy to set up and have many benefits. Cover crops are things such as grasses, legumes, or forbs that are planted in fields or in gardens to provide protection against bare soil. They help reduce soil erosion, increase organic matter, promote biodiversity, and improve soil health. We can see a picture of cover crops in the top right section of the slide. The most important thing to remember about this slide is that there are plenty of methods we can use to combat soil degradation, and when they're all used in conjunction together, they can further strengthen one another and they promote healthy soils. See you on the next slide, which will be my conclusion slide. So we've come to the end of my portion of the presentation on soil degradation, and I wanted to leave you with something to think about. Remember when I told you to take note of the 23 hectare statistics I converted into acres at the beginning of my portion of the presentation? And I told you this is going to be important? Well, this is where it matters. To close and put everything into perspective, by the time this 12-minute presentation is concluded, roughly 682 acres of land will have been degraded. That's about 47% of Cal Poly Pomona's campus that would become unusable and unable to support life. I went ahead and created a perimeter of 682 acres using Google Earth Pro, as seen on the screenshot of the right-hand side of the screen. So you can see what that looks like. That's this part here. So I started by creating the perimeter at the greenhouses just behind the CPP farm store and encompassed almost all of the campus, running up to the Kellogg house, running along the 10 freeway, and ending just beyond the fields to the left of Building 45. So imagine the next time you come to campus and there are no more green pastures, no more plants, no more animals, and possibly no more buildings because the land is so eroded it can't support any life. That's so scary to think about. But we have the power to curb soil degradation with the solutions I provided if we put our best foot forward and are proactive about stopping the problem.
Hello class, I'm Ramon. Today we're going to be talking about water contamination. So how's it created? So water pollution is the introduction of harmful substances into water bodies like the rivers and oceans, disrupting their functions and harming ecosystem. It includes pollutants such as chemicals, waste, and microorganisms, as well as energy discharges like radioactivity, excessive heat, soil erosion, and urban runoff can introduce sediments into water bodies, which can clog waterways and harmful aquatic ecosystems. Water contamination is a complex issue that requires a collaborative effort. By implementing preventive measures and promoting responsible water management, we can safeguard our water resources for future generations. Like you can see in the image, oil spills, also livestock, chemicals, fertilizer goes into the water, plants, also trash like plastic, the factories, the landfills, all those things, even the combustion of the cars. Now, moving on with the problems created by the water contamination. I mean, it's a really big issue. So, drinking contaminated water can lead to serious health issues. Each year, around 1 billion people fall ill due to unsafe water. Moreover, low-income neighborhoods often bear the brunt of this problem as they are typically located near the most polluting industries, putting residents at greater risk. Those waters have diseases from like unsafe. It includes like cholera, gonorrhea, and typhoid. Even in wealthy countries, sewage leaks and runoff from farms and urban areas introduce harmful pathogens into waterways. So how are they created is by agricultural sewage and wastewater, oil pollution, radioactive substances, point source pollution, and transpondering, how I mentioned earlier. So all these problems create that water contamination, and it's bad for our health. So how do we combat water contamination? A simple way to help this solve the problem is to avoid flushing plastic down the toilet. We clean up after pets. So cleaning up after pets is crucial to prevent bacteria and waste from contaminating water system. Dispose of it in a bag made of recycled plastic and throw it into the garbage. Navigating carp maintenance can lead to chemicals like coolant and oil leaking into the groundwater. Regular maintenance not only enhances performance but also reduces harm emissions. Also, fertilizer and nutrient management techniques cover crops, buffer zone, efficient animal waste handling, conservation targets, water regular quality checks, and effective drainage systems to minimize runoff. So as you can see in the image, do not litter, use less water, dispose oil properly, use environmental friendly detergents, reuse items, use less plastic, and do not dispose items down the toilets.